Hey everybody, let's continue with section 9.3. I want to take a moment to summarize the forms of the ellipse when the center is at the origin. So at the end of the last video, when the major axis was on the x-axis, you saw that the equation took the form x squared over a squared plus y squared over b squared equals 1, where both a and b are greater than 0, and the equation b squared equals a squared minus c squared. And when the major axis is on the y-axis, the form of the equation is going to be x squared over b squared plus y squared over a squared equals 1. Still, a and b are greater than 0, and b squared equals a squared minus c squared. And so, when you're doing these problems, you can always know which one is the major axis by a couple of ways. First is the larger value in the denominator for either of these is going to be associated to the major axis. And when we have it just in the general forms, the a squareds are representing the vertices of the ellipse. And in the video we saw with Professor Sullivan, he stated near the end of the derivation that the a is, since a is the vertex and c is the foci, that a is going to be larger than c, and so that's going to also signify that that is the major axis. And so you can see that when this is the case, when you have the major axis is the x-axis, I think about it as like a football is being thrown, so it's horizontal. And when the major axis is the y-axis, I think about it as the football is being punted. And so it kind of just helps keep the analogy straight for me. And let's go ahead and look at this example to see how we can write the equation of the ellipse. So we have the equation of an ellipse with center at the origin, a focus is -3, 0, and a vertex is 5, 0. And so, just like the parabola, I find it helpful to just do a sketch. And so we have the origin is the center, a vertex is 5, 0, and foci is -3, 0. Well, a focus is -3, 0. We know that there's two focus now, so the foci, so there has to be one at 3, 0, and there's going to be two vertices, so there would have to be one at -5, 0. And so we can determine that the major axis is the x-axis. And therefore, it's going to take the form x squared over a squared plus y squared over b squared equals 1. And the a is representing the vertices, the distance from the center to the vertex. So since that is a distance of 5, a squared must be 25. And the thing that we use to solve for b is we know that b squared is equal to a squared minus c squared. And our a is 5, so this is going to be 25, minus our c, which is distance of 3, so 9. 25 minus 9 is 16. And so b squared is equal to 16, well, automatically giving our 16 there. So x squared over 25 over 25 plus y squared over 16 equals 1. So on the minor axis, you're going to have 0, 4, and 0, negative 4. And so the ellipse, just doing our sketch, would look like this. Alright, so that's this problem, and let's work on another one in the next video.